Hi everyone, I hope you are doing well. I hope your spring break was amazing. Mine was okay. Honestly, I did have some plans. I wanted to just chill and also do some stuff about my bedroom because, like, my bedroom is just kind of sad. It doesn't have a specific design. So I just wanted to just add some character about myself to my bedroom and just make it more beautiful. Apparently, I didn't have that much time, so basically the project was not that much successful, and I couldn't make any change, which I'm kind of sad. But I had some fun, honestly, with my friends and family. So in general, it was good, but the bedroom project wasn't successful, which actually makes me kind of sad. But overall, I hope you all had amazing break and enjoyed like the time of being with your family, friends, and the hobbies that you liked. So today we're going to talk about chapter 6, part 2. Um, I guess it has like maybe four or three sections, which I'm going to talk about. Let me share my screen. Yep. So I guess you already remember this picture. It was about different parts of brain, but the question here is how we can actually understand what part of brain does what exactly. For example, here we can see this is frontal lobe, but how we can just understand, for example, frontal lobe can just do decision making or problem solving. The key for that, okay, wrong slide, bear with me. Yeah, the key for that is imaging the brain or brain imaging. We have like different procedures for doing so. The first one and most popular one is PET or PET, which is like positron emission tomography. Basically, we're gonna add radioactive isotope, and we're gonna actually measure metabolic activity in the brain. The second one is functional magnetic resonance or fMRI. This is basically using a magnet to record changes in oxygen level. For example, if some part of the brain, let's say frontal lobe, is just has higher level of oxygen, we're gonna understand that, okay, for example, in problem solving, frontal lobe is actually doing the work. Another way, another procedure for understanding what's going on with the brain is event-related potentials or ERP. Here we're gonna use electrodes. So basically we have different ways for brain imaging, but each of them has like different criteria. But the keyword for each one of them is specific. For example, if I would ask you, okay, what we're gonna do in PET scanning, you're gonna say that it is all about radioactive isotope. If I would ask you what we're gonna do in fMRI, you're gonna say that, oh my God, it's all about oxygen level. I know that. I mean, what kind of question is that? And if I would ask you, okay, what we're gonna do during ERP, you're gonna say that it is all about electrodes. So just make sure you know everything. Also make sure you know the whole task and functions of each part of the brain. For example, if I would ask you what frontal lobe gonna do, you have to just understand that, okay, it is all about decision making. And for example, if I would ask you about like, okay, what part of the brain is doing the vision part, you have to understand that, okay, for example, this specific part is just responsible for that. Here is another example. You can see here is just PET or PET, which actually based on radioactive. For example, here we can see that, okay, this part might be more involved in just that specific task because we can see like a different color here and we can just track radioactive isotope here. How about fMRI? We can see that based on the oxygen level, for example, this part of the brain, again, frontal lobe, is just turning to red. So probably we have like a higher level of oxygen. So this part might be more involved in that specific function. So this is the way we're gonna track brain activity. Again, we have the same picture. And like you can see, each part of the brain is just responsible for a specific function. Read that carefully. Definitely we have at least one question or maybe more, or maybe a matching, I don't know, in your test too. So using those procedures that I mentioned, we can answer different research questions. For example, we can say that, okay, if we're gonna answer that how does brain activity changes over time, we can use fMRI for answering that. If we're gonna answer that what brain regions are responsible for a specific activity, we can use like PET or PET screening and just understand, okay, based on PET, this is the answer for the research question. We can also look at the problem more in a developmental way. We can just track the problem in infants, then in toddlers, and then in preschooler children. There are some terms and concepts when it comes to brain development. For example, we already talked about brain plasticity. It is the way brain gonna respond to the environment. We know that as we grow up, the level of brain plasticity gonna be low. We already talked about Jeannie, the girl who was just basically abducted, and she couldn't grasp language after her puberty. She couldn't understand and make sense of syntax and semantic packaging and that kind of stuff, because basically she didn't have proper education in a specific amount of time in a sensitive period, and basically right after puberty she cannot understand how language gonna work. So it is all about brain plasticity. Probably in her case, her brain was not like that much flexible to just understand and absorb the impact from the environment. But for example, in children, younger children, for example, infants and toddlers, they have like high level of brain plasticity, so they can just, they can be like a sponge. They can just absorb everything from the environment. We have two other concepts here: experience expectant processes and experience dependent processes. So when it comes to experience expectant processes, it is all about experience available in the environment, which is kind of mutual and common between all members of a species. For example, let's say vision development. We already talked about this. In early capacity in infancy, we know that vision comes when all infants all around the world, they are just 6 months old, right? Yes, there might be like one or two cases that develop vision in a different pace. They might be a bit late, but eventually we know that all children in a specific age range, let's say between like 5 months to 8 months, can develop this talent in themselves. Yet, those kind of talents like vision development, like cognitive development, that kind of stuff could be experienced expectant processes, because they basically mutual between species, like all human beings gonna be same. Yet we have another term, experience dependent processes, which basically is specific to region and culture. And just depending on the culture and the country that you're gonna grow up, those talents might be different. For example, let's say language. Based on the country that you're gonna born, you're gonna have a specific phonemes that might be differ from children in other countries. Let's say Vietnamese children, they do have like 100 phonemes from the beginning, so they do know more phonemes compared to Western children. So that kind of a stuff that is mutual to a specific culture or a specific country, or let's say a specific region, gonna be experience dependent processes.